Now we are going to solve question number 317 from Irodov, and in this question it is given that a pitot tube is mounted along an axis of a gas pipeline whose area cross section is equal to S. Assuming the viscosity is negligible, find the volume of the gas flowing across the section of the pipe per unit time if the difference in the liquid column is equal to del H. So this is our corresponding figure. From this figure we can draw this diagram. So in this diagram, this is the inlet section and this is the outlet section, and we are considering 4 points A, B, 1 and 2, and this AB section is filled with a liquid of density rho 0 and density of fluid or gas is rho. Now first of all, we'll consider the Bernoulli equation for point A and B. If we consider the Bernoulli equation for point A and B, then it will provide P B equal to PA plus rho naught G del H, because our corresponding figure was like this. This was our segment of the pipe, and this is a segment of our pipe, and this is the liquid height at this limb, and this is the liquid height at this limb, and the height difference between two is del H. Now we are considering point A here and point B here, and let again 2 points. One point is this, point 1 is here and point 2 is here, and let this is in inlet segment gas is flowing, and volume of density of the gas is rho and density of the liquid is rho naught. So from this equation, if we apply the Bernoulli equation at the segment 1 and 2, then we will find PB equal to PA plus rho G H2. Again, if we apply the quantity equation, Bernoulli equation at the point 1 and 2, from this equation we will get P2 will be equal to P1 plus rho G plus half rho V square. So from this two equation, as we know, from this figure, P1 is equal to PA and P2 equal to PV. So we can write P1 is equal to PA and P2 equal to PV. So after substituting this value of PA and PV, we can find PA plus rho, we can find PB equal to PA plus half rho V square. So from this two equation, this is our equation number 1, this is our equation number 1, this is our equation number 2. If we compare this equation 1 and 2, we will get rho 0 G del H is equal to rho 0 G del H will be equal to half rho V1 square. Now from this equation we can find the value of V1. So V1 will be equal to 2 rho naught G del H divided by rho. So velocity or V1 or V, we can express this at this term as V also. So we can find the velocity of the gas will be V equal to root under 2 rho naught G del H divided by rho. So this is our required velocity of the gas in the pitot tube. Now we have to find the volume flow rate. If we want to find the volume flow rate, then our volume flow rate Q will be equal to area of cross section, and it is given in the question that area of cross section is equal to S and its velocity is V. So we'll find the volume flow rate Q will be equal to S into root under 2 rho naught G del H divided by rho. So this is the volume flow rate inside the pitot tube.